Welcome students to the next video of discrete math series. This is the second video related to generating function. So if you are new to the channel and have come across the video for the very first time, please watch the previous video. I already have created a separate playlist for recurrence relation, and in that you will be able to find all the videos related to recurrence relation and generating function. So today we are going to solve two more recurrence relation problem where I will be using generating function to solve it. Please subscribe the channel and also like the video in case if you enjoy it. Right, so let's start. So first of all, if I talk about this particular problem, it is a linear recurrence relation with constant coefficient of degree 2, and the initial condition given are a0 is equal to 6 and a1 is equal to 30. So how do I solve this problem? So let us first write it. We have ak is equal to 5a k minus 1 minus 6a k minus 2. And let us consider that let gx is equal to summation k varies from 0 to infinity ak x to the power k is a solution to this recurrence relation. Now I hope you are clear about the fact that the solution of a recurrence relation is basically a sequence, and a generating function is just another way of representing the sequence. Okay. So if I am taking gx as the solution, basically I am taking its corresponding sequence ak, which is the solution of this recurrence relation. So how to solve it? Let us look at the steps very carefully so that you don't miss anything here. And before I proceed, I also want to write its expanded form so that you can clearly understand. So if I take k is equal to 0, I will get what? I will get a0. If I take k is equal to 1, I will get a1x. If I take k is equal to 2, I will get a2x square and a3x cube and a4x to the power 4 and so on. These are the all terms of this sequence. Now what I do, I take the summation here. Let me call this equation as equation number 1. So I apply summation in both sides, summation ak, and I also multiply it by xk, means first I multiply it by x to the power k and then I take the summation. So the same thing I have to do in the right hand side. So here I have 5 a k minus 1 x to the power k, and then I take summation over it, and minus summation 6a k minus 2 x to the power k. I hope you got it. I have actually done two things. First I multiplied both sides of equation by x to the power k, and then I took summation in both sides. But the important thing that you need to understand here, that what will be the terms up to over which I am going to run the summation. So you can clearly see that for this I need to start the summation at k is equal to 2, because if I take anything less than 2, for example if I take k is equal to 1, then I will get a minus 1 minus 2, so a minus 1, I will get a term like a minus 1. So that will create problem because we are considering that the terms are starting at a0. So that is why the summation I am starting from k is equal to 2 to infinity. And since I am starting the summation at k is equal to 2 here also I have to start at k is equal to 2 to infinity, and here also I have to start at k is equal to 2 to infinity. Now if you look at this, it will be like what? It will be k is equal to 2. So if I can write, it will be a2x square plus a3x cube plus a4x to the power 4 and so on. There are infinitely many terms. Here 5 is a constant, and so I can take 5 out, and if I take the summation, first term is k is equal to 2, so it will give me a1, because if I take k is equal to 2, 2 minus 1 is 1, and then x square, right? And if I take k is equal to 2, k is equal to 3, so I will get a2 x cube. And if I take k is equal to 4, then I will get a3 x to the power 4, and so on. So this is what we are getting. And minus, if you look at this term, 6, and here it is starting at k is equal to 2, so it will be a0 x square, then k is equal to 3, a1 x cube, then a2 x to the power 4, and so on. So this I have written just to be clear that how this works. Now I want you to notice one very important thing, that if you look at this recurrence, this generating function gx here, this bracket, this left hand side bracket actually is what? It is starting at a2 x square. So this term is nothing but g of x minus a0 minus a1 x. In the right hand side, I can take this x term constant, x term outside this means x common I can take. So I can get 5x. And when I take x common, look at this very carefully. The first term will be a1x. Let me write it. First term will be a1x. The second term will be a2x square. Third term will be a cube x cube, and so on. And here, if you look at this, I can take x square common. So I will get 6x square, and then I will get a0 plus a1x and plus a2x square, and so on. I hope up to now there is no doubt. Okay. So let us continue with the solution. As we have seen in the previous page, we have gx minus a0 minus a1x. And if you look at this, a0 is equal to 6 and a1 is equal to 30. So what I will get? I will get here gx minus a0. So minus a0 is means minus 6, and then a1x means 30x. This is the left hand side. And what I will get in the right hand side? So you see we have 5x, that is the term. So I write 5x here. And if you look at the other term like a1x plus a2x square, so basically it is starting at this term a1x plus a2x square. So this bracket is nothing but gx minus a0. So gx minus a0 is equal to 6. So I write here gx minus a0. So gx and a0 value is equal to 6. And what is there in this term here? 6x square. So I write 6x square here minus 6x square, and in the bracket that I have here a0 plus a1x plus a2x square, that is nothing but this generating function gx, right? I hope you got this point, because I have to change the page because of lack of space. I hope you are not getting confused. Better write the terms and do it yourselves together, so that you don't miss any point. Now what I am getting gx minus 6 minus 30x, and in the right hand side I get 5x gx minus 6 into 5, that is 30x, and minus 6x square gx. So now I am going to take all the gx term in the left hand side, and we already have a gx term here. So I will write gx common, and here I will get 1, and then from this I will take in the left hand side minus 5x, and then I will get plus 6x square. And you see we have a minus 30x term in the left and minus 30x term in the right. So that will be cancelled, and this minus 6 can be taken in the right. So I will get plus 6, right? So what we got here, let me write here so that we can save some space. So gx we got 6 by 1 minus 5x plus 6x square. And this is the first part of the problem. Now what is the next part? That will involve some prior knowledge. So I will explain that as well. Don't worry about that. So if I take this gx here, I am writing it separately. and then I will factorize the denominator. So denominator here is 6x square minus 5x plus 1. So if you factorize this, it will be like, let me write it, 6x square minus 3x minus 2x plus 1, right? So this will be 6 by 3x you can take common, and you will get here 2x minus 1, and from here you can take minus common and you will get 2x minus 1. So you will get 6 by 2x minus 1 into 3x minus 1. And if you allow, I can also write it, and I will explain why it is better to write in the form of, I can take minus common from this, minus common from this. So I can write it 1 minus 2x into 1 minus 3x. The next thing that we have to do, we have to write its partial fraction, and which I am writing separately. So if I write its partial fraction like 1 by 1 minus 2x into 1 minus 3x, right? So how do you write the partial fraction? You write a by 1 minus 2x plus b by 1 minus 3x, which is equal to a times 1 minus 3x plus b times 1 minus 2x, and then you have 1 minus 2x into 1 minus 3x. Now you compare both sides. So the denominator is same, numerator is 1 here, and if you look, this is a, the constant term is a, and from there I get constant term is b, so we get a plus b, and minus, it is 3ax, so x common, I can write 3a plus 2b. Okay. Now how do you solve? You compare the constant terms. So a plus b I got is equal to 1, and I got not 1, there is 1, correct, the constant term is 1. And what is the coefficient of x in the left hand side? No coefficient. So I am basically getting minus 3a minus 2b, because basically x is coming with a minus sign, so I am including the minus term with the coefficient, and that is equal to 0. So I have got two equations, a plus b is equal to 1 and minus 3a minus 2b is equal to 0. Now I have to solve them. So to solve them, I am going to the next page, right? Keep this in mind and note it down that a plus b is equal to 1 and minus 3a minus 2b is equal to 0. So we have these two equations. So let us solve them. So minus 3a and minus 2b is equal to 0. And if I multiply here by 2, I will get 2a plus 2b is equal to 2. So if I add these two equations, minus 2b and plus 2b cancel, minus 3a, 2a. So I will get minus a is equal to 2. So what I get, a is equal to minus 2. And if I solve it here, what I will get, b is equal to 1 minus a from this equation. So 1 minus minus 2 means 1 plus 2 is equal to 3. So the gx term that I got in the previous page was what? It was 6 times 1 by 1 minus 2x into 1 minus 3x. Okay, and I have written this 6 times, and using the partial fraction I am writing it minus 2 by 1 minus 2x and plus 3 by 1 minus 3x. Let's verify whether it is okay or not. If you multiply, you will get minus 2 from here and 3 from here, so that will give you 1, and plus 6x and minus 6x. So this is the basically partial fraction. Now the next thing is, and this is important, actually what was my gx? My gx was ak x to the power k, and k varies from 0 to infinity. And here in the right hand side I am getting 18. If you look at this, 6 into 3, I am looking at this term first, and 1 minus 3x to the power minus 1, because my purpose of writing this expression in this form is to generate a series here, and that I will discuss that how to generate. And so what will be the next term? This 6 into minus 2, that is minus 12, and 1 by minus 2x can be written as 1 minus 2x to the power minus 1. Okay. So what we are going to do next is important. So let us do it. So if you now look at this expression here, we can use expansion to write the expansion of it, and if I write the expansion of it, in the left hand side it will remain same, that is k varying from 0 to infinity ak and x to the power k. And what I will get here, I will get to 18 1 plus 3x plus 3 square x square plus 3 cube x cube and so on. And what I will get here, I will get minus 12 1 plus 2x plus 2 square x square plus 2 cube x cube and so on. I hope you got this point, because in the previous video I discussed one thing, a very important result, that if I have to write the expansion of 1 minus x to the power minus 1, I can write it as 1 plus x square plus x cube and so on up to infinity. So basically in place of minus x we have minus 3x here, and in place of minus x we have minus 2x here. So this is how the expansion will look like. But because we want to compare this expansion from the left hand side, so I need to rewrite it in the summation form. So left hand side will not change, it will remain same, k varies from 0 to infinity. And if I have to write this in summation form, how it will look like? So it will look like 18 and summation k varies from 0 to infinity 3 to the power k x to the power k. How did I get it? Because if you take k is equal to 0, 3 to the power 0 x to the power 0 will be 1, k is equal to 1, 3 to the power 1 x to the power 1 and so on. And if you write this in the summation form, it will look like summation k varying from 0 to infinity, and this will be 2 to the power k x to the power k. Okay, now I can combine both of these terms. So if I combine both of these terms, in the left hand side we have the same k varying from 0 to infinity ak x to the power k, and in right hand side, and this is important because we are almost at the final stage, so I will rewrite the expression 18 into 3 to the power k minus 12 into 2 to the power k and then x to the power k and k varying from 0 to infinity. I can take 18 inside the summation because it is independent of k terms, and then for both the terms we can use just one common summation term. What was the reason behind it? Because I want to make it look like the expression in the left hand side so that we can compare, and if I compare, in the end we have got my answer. So what is the answer? I am writing the answer final. So if you compare, the summation is same, k varying from 0 to infinity, x to the power k power is also same, and we are getting ak is equal to this. So the solution is ak is equal to 18 into 3 to the power k minus 12 into 2 to the power k, and that is what the solution of this recurrence relation will be. I hope you have got the point. The process that we have followed is that we started with a generating function, and then we multiplied both sides by x to the power k, took the appropriate summation, got the gx value, and after getting the gx value here we separated it using the partial fraction, and then at this stage what I did, I wrote the expansion, and then I wrote the expansion back in the summation form and compared both sides. We got my answer. So let me write the answer clearly here. Possibly for some of you it will be slightly difficult. So 18 into 3 to the power k minus 12 into 2 to the power k. So that is my solution. Okay, so now let us move to the next problem. Okay, so now let us take this problem here, and in this problem we have a recurrence relation an is equal to this for n greater than 1, and they also have given us the initial condition. So how to solve it? So the recurrence relation given is an is equal to 8an minus 1 plus 10n minus 1, and this is meant for n greater than 1, right? And a1 is equal to 9. But one thing I want you to understand here in the beginning itself, that if you look at this, they have given the initial condition a1, but the a0 value is not provided. So let us try to first define a0 from our side so that it satisfies the recurrence relation in accordance to it. So if I take what you call a1, if I put n is equal to 1, I am getting a1 is equal to 8a0, because 1 minus 1, and plus 10 to the power 1 minus 1 is equal to 0. So this will give me what? a1 is equal to 9, a1 is equal to 9, and 9 is equal to 8a0, and plus 10 to the power 0 is equal to 1. So we are getting 8a0 is equal to 9 minus 1, that is 8. So we are getting a0 is equal to 1. So there is no harm in setting the value a0 is equal to 1, because we will require this to solve the generating function. So the next is that as we have seen in the previous problem, I start with the generating function, that is gx is equal to summation k varies from 0 to infinity ak x to the power k, right? And we have the equation like an is equal to 8an minus 1 plus 10 to the power n minus 1. So first what we are going to do, we are going to multiply the both sides by x to the power k. So an x to the power k, or because we are working with n terms, so let us multiply it with x to the power n, okay? Because here also because our expression is in terms of n, so let us make one correction. Let us do this one correction. It is important because we should keep the same symbol. So just let me write this expression. I think it will be better here. So let me use the summation n varies from 0 to infinity and an x to the power n. I hope you got this point, because the expression is given in terms of n, so I am also taking it in terms of n. So now here I am going to multiply both sides by x to the power n, and here 8an minus 1 x to the power n, and plus 10 to the power n minus 1 x to the power n. And once we multiplied, we are going to take the summation also in both sides. So I took the summation in both sides, right? And how the summation should be, what will be the value over which the summation should run? So it is very obvious that we have an minus 1. So if I take n is equal to 0, it will be like a minus 1. So n minus 1, because of an minus 1, I should start with n is equal to 1. So I take n is equal to 1 to infinity, n is equal to 1 to infinity, and n is equal to 1 to infinity. This is an important point, because when we are taking the summation, we have to be very clear that the summation should run over what particular value of n, because it is an minus 1 and our count is starting from a0, because we have taken a0 or a0, which is equal to 1 here. Now I'm going to work further. So if I do this expansion, it will be what? It will be a1 x plus a2 x square plus a3 x cube, and so on up to infinite. What will be there in the right hand side? 8 being a constant will come out of the summation, and for n is equal to 1, it will be a0 and x to the power 1, so a0 x rather, and plus for n is equal to 2, it will be 2 minus 1, so a1 x square. For n is equal to 3, it will be a2 x cube, and so on. And what will be this term? For n is equal to 1, it will be 10 to the power 0, means 10 to the power 0 x to the power 1, plus 10 if I take n is equal to 2, it will be 10 to the power 1 x square, then 10 to the power 2 x cube, and so on. I hope you are not getting confused with the expansion that I am writing. Now if you look at this term, and the generating function here, basically what is this generating function? This is a naught plus a1x plus a2x square plus a3x cube and so on. So if you look at this left hand side, gentlemen, you have a naught x, a2x square. So basically this is gx and minus a naught. And if you look at the right hand side, you can take x common. So you will get 8x, and then in the bracket you will get a naught plus a1x plus a2x square. So it is nothing but 8x times gx. I have just written it directly. I hope you understood that x can be taken common, and what you will get inside the bracket is nothing but this gx. And here you are getting a series that is x to the power 1. So I take x common here. The first term is 1, next term is x common, so it will be 10x, then the next term will be 10 square x square and so on. Okay. Now let us write this here. So there are certain condition we have already set. So a naught is equal to 1, so I write gx minus 1 and 8x gx, and because we want to find gx, and plus x, and this is an infinite series whose first term is 1 and whose common ratio is 10x. So the summation formula is a by 1 minus r. So I will write it 1 by 1 minus 10x. Okay. Now let us move to the next page. So now we have this expression. So basically what is my aim? My aim is to get the value of gx. So I bring the gx term in the left hand side. So gx minus, and this term, that is 8x gx, here we have. And in the right hand side we have x by 1 minus 10x and plus this 1, that term I will take in the right hand side. Now I can write it gx and 1 minus 8x, and if I look at this term, I get x plus 1 minus 10x by 1 minus 10x. So we got what? We got gx is equal to 1 minus 10x and plus x. So basically I will get 1 minus 9x in the numerator, and here we have 1 minus 10x, right? And this term will also come here, so it will be like 1 minus 8x. Now at this stage we need to be able to write the partial fraction, and I discussed the process of writing the partial fraction in the previous problem. In this I am leaving this for you as an exercise. I am writing it directly. So I can write it 1 by 2, and I am writing it 1 by 1 minus 8x plus 1 by 1 minus 10x. How to do that? You write it a by this plus b by 1 minus 8x and then solve the equation and get it, right? Please do it. So now I write gx, which is summation n varies from 0 to infinity, that I have taken a n x to the power n, and here I get 1 by 2 and 1 minus 8x to the power minus 1 plus 1 minus 10x to the power minus 1. So if you expand this again, I hope this time you will be able to write it directly in the summation form. So it will be 8 to the power k x to the power k. K varies from not k. Again I made the same mistake. I am using the notation n notation. So let me write 8 to the power n. It is or let me expand also, because I think some of you may find it slightly difficult, because solving the problems should be done in detail to avoid any confusion. So let me write the detail for your convenience. Okay. So gentlemen, what I am saying is that if I look at this expression, I will get 1 by 2, and this expansion will be 1 plus 8x plus 8 square x square and up to infinity. And what will be this expansion? 1 minus 10x expansion. It will be 1 plus 10x plus 10 square x square and so on up to infinity. Okay. Now let us write this in summation form. So in summation form, how it will look like? It will look like 1 by 2, and here I take the first series summation. So I will write n varies from 0 to infinity, and here I will write 8 to the power n x to the power n. And if I look at the second term, it will look like summation n varies from 0 to infinity 10 to the power n and x to the power n, right? Because the summation is starting from 0, so the first term in both the cases, if I take n is equal to 0 here, 8 to the power 0, x to the power 0 is 1, and here it will be 10 to the power 0, x to the power 0 is equal to 1. So I can combine both this term here, and the summation is same, so I write n is equal to 0 to infinity, and 1 by 2 is the constant term, and I get 8 to the power n plus 10 to the power n, and then x to the power n, right? We combined both the terms. So from here I am getting 8 to the power n, from here I am getting 10 to the power n, and then x to the power n. And this is equal to what? This is equal to summation n varies from 0 to infinity a to the power n x to the power n. So you look at the left hand side, summation n varies from 0 to infinity. In the right hand side also, summation n varies from 0 to infinity. We have x to the power n here, we have x to the power n here. So what is an? The an that we are getting is 1 by 2 8 to the power n plus 10 to the power n, and that is my answer. That is the solution of the original problem, and this is giving me the value of an. Okay, so we have taken two problems. I think let me also help you in understanding this finding the partial fraction part, which I told you that you can do it yourself, but I think that I can do this for your convenience, right? You will be solving other problems, but please do some practice so that you are thorough with the concept. So if I have to do the partial fraction for this part, which I am writing here, 1 minus 9x by 1 minus 10x into 1 minus 8x. So how I will write it? I will write it a by 1 minus 10x plus b by 1 minus 8x. I think it is better if I move to the next page, because it will there'll be a lot of space in the next page. So this is what we have, and we have to write the partial fraction of it. So if I write the partial fraction, I will write a by 1 minus 8x plus b by 1 minus 10x, right? So what you do, you compare both sides, which you can write here, that a times 1 minus 10x plus b times 1 minus 8x, and in the denominator you have 1 minus 8x into 1 minus 10x. So if I compare, I will get 1 minus 9x is equal to, in the right hand side I will get a plus b, that is the constant term, a here and b from here. And what will be the coefficient of x? Minus x. Coefficient of x will be 10a plus 8b. Now if you compare both sides, you will get a plus b is equal to 1, and you will get 10a plus 8b is equal to 9. You have minus x here, you have minus x here, so it is equal to 9. Now to solve it, I can multiply this equation by 8. So I will get 8a plus 8b is equal to 8. And now I subtract, so it is minus minus minus, 8b and 8b cancel. I will get 2a is equal to 1, so this will give me a is equal to 1 by 2. And since a plus b is equal to 1, so b is equal to 1 minus a, that is 1 minus 1 by 2. So this part I left for you earlier. So if you rewrite this expression, that is 1 by 2 by 1 minus 8x in place of a, in place of b I can write 1 by 2 1 minus 10x. So which I can take 1 by 2 outside, and I can, means 1 by 2 is common in both the numerators, so I can take it outside and I can write it 1 minus 8x plus 1 by 1 minus 10x, right? So this is what I have done here in the previous problem directly, and I hope you have got it, that I was writing this expression as this expression. So in this video we have discussed about the process of solving the recurrence relation using generating function. And if I summarize it, that what is the process in all the three problems, one in the last video and two of the problems here in this video, we always start with the generating function, that is gx, right? And we always take the generating function summation a k or a n, depending upon what is the symbol they are using in the particular problem. And then we multiply the recurrence relation in both sides by x to the power k, while taking the summation, that where at what value or over what value it will run, that is important to decide. And that is the one point you need to be careful about, that you start with that value of k, so that it does not give any negative subscript of that, a naught kind of term, a naught, a1. It should start with a naught. It should not start with a minus 1 or a minus 2. Okay. And finally you get an expression in terms of gx expression, which may be in terms of some function of x, and then you expand that function and write that in the summation form, and then you compare both sides and solve this problem. So this is the whole process of solving the generating function, using generating function solving the recurrence relation, right? So we have completed this idea of recurrence relation, and all the concept related to recurrence relation has been discussed in the previous videos. The playlist has already been created for you, so please watch the videos in the sequential order, and like the video also, because it will motivate me. I am putting a lot of effort to create this video. So and only way to know whether you are liking the video or not, just by putting the appropriate comments and giving me a thumbs up, so that I am also motivated to upload videos of all the next topics as well. So this is all from my side in this video. Have a great day and thank you.